Hello, welcome to Mr. Lamb Science Court. Earlier we did a demonstration with ice melting blocks, and we used a commercial thing which used a black plastic and a black piece of aluminum. And if you have seen that one, you saw that the aluminum melts the ice much faster than does the plastic. It has to do with heat conductivity, okay, and that measures how fast something is conducted from one place to another. The units are kind of crazy. It's BTUs per hour degree Fahrenheit foot, and if you want the metric equivalents, that would be calories. Hour would be the same, degrees Celsius, and probably a meter. Basically, we're not going to worry about the units, okay, because those are kind of crazy, and if you're working with 5th grade students or around there, that's a unit I don't think I would give to them. However, the numbers are very evocative and very easy to understand. Copper is the most conductive element that we have, at least the common elements, and its number is 223. Okay, and again the unit is BTU per hour degree Fahrenheit foot, but basically it's a fairly high number. Aluminum is number 2, and it is about half that of what copper is. So in terms of conductivity, copper will transfer heat from one place to another about twice as fast as aluminum will. I found number 3, which is brass, and it's 64, so it's about half of what aluminum is. And then cast iron, which I do have an example here, is a range depending upon how you cast it, but the highest number I found was 47. So you can see that copper is going to conduct heat a lot easier and faster than cast iron, which if you do any cooking, you know that that's the way it is, because a copper skillet will warm up far faster than a cast iron skillet, and in part that is due to the conductivity, and then in part it's due to the mass of the skillets. Cast iron is a lot heavier usually than a copper skillet, and that has to do with specific heat. Okay, and specific heat measures how much heat it takes to raise 1 gram, and here I'm switching to metric because that's what I'm more familiar with. I don't do anything, never did anything with heat conductivity in terms of numbers in units, but calories we use all the time in chemistry. Water has a very high specific heat of 1. It doesn't seem like much, but there's very few substances that have a specific heat greater than that of 1. And you see this by it takes forever to boil water. The legend has it water won't boil unless you stop looking at it. And the unit is in calories per gram degree Celsius. And so the mass is involved there. A heavy object will certainly take longer to warm up than a light object. And we all know that again from cooking. So if we have water as 1, aluminum is actually fairly high for a metal at 0.22. To give you a comparison, we have cast iron at 0.11, half that of aluminum. Carbon steel is 0.12, and chromium, and I put chromium because stainless steel, which I have an example of, is a combination of chromium and carbon steel, is 0.11. I couldn't find a number for stainless steel, but I figured between chromium and carbon steel, it's probably about the same. And I forgot to show you this one. Copper is 0.092. So you can see that aluminum for a metal has a pretty high specific heat. Uranium, as a comparison, was 0.02. So aluminum is 11 times higher specific heat than uranium. And of course, I do not have a sample of uranium here. So anyway, the reason I bring this up is you could easily say, Mr. Lamb, that demonstration you did before was wonderful and it was great to see and all like this, but I don't have a budget to buy these blocks, and that certainly is understandable. It is hard to get a good closet of science stuff, but you don't really need to buy the blocks. They're nice, they're cute, they last forever. Having bought them once, you could use them your entire career, no matter how long you go. But let's say that you just don't have the budget for it. Well, that's what I did, is that I went into my kitchen and I got some stuff. Cast iron skillet, stainless steel, aluminum, and copper. Okay, so I'll lay these out. And then I'll take and I'll put an ice cube on each one, and we'll see what happens. Now you can see that maybe this isn't quite level or whatever, but you've got enough liquid forming here in the stainless steel to where it's moving some. But if I take this and tip it, there's a little bit of water there. If I take the aluminum and tip it, we see a lot more water, and I just drip some on the stainless steel. Okay, so we can see that it's going pretty fast. The copper has some, but not a whole lot, and the cast iron again has some. So all of these will melt the ice far faster than the plastic. And if I could just take if I want an insulator, I'll just put it on the wood here, and then we'll watch what happens there. And you can try all kinds of different things, and you can get the kids to say, kids, you can go home, and if you have some ice cubes at home, which everybody does, you can show your parents and try all kinds of different things. Grab a towel, see what happens if you put it on a towel. Check it out with the various different metals that you have in the kitchen. Try different plastics. Just, it's something that the kids then can do with their parents, and they can show their parents and say, Mom, Dad, look at this. Look at how aluminum does so much more than the other metals. And it's a combination of being very conductive, and it basically stores a fair amount of heat in it, more so than any other metal. Excuse me, because a measure of how much heat it takes to raise 1 degree Celsius is a measure of how much heat is stored in there. And so they all start off at the same temperature. So they would drop 1 degree Celsius, and there's enough heat in there, and it's conductive enough to where the heat will flow from all the way out here into here to try to maintain the same temperature. and it can't because the ice cube there is making this part right here very cold. And so the heat is going to flow from out here into where the ice is, and because it's thermally conductive, it does that very well, and because it stores a fair amount of heat, it does that pretty well. And so overall, aluminum then is something that will melt ice much faster. And we can see this here by how much water is being stored here as opposed to the stainless steel, which has gotten some, but not that much. And the copper, being very conductive, has a fair amount, okay, but it doesn't store as much heat. So it's going to do very quickly melt ice, but it will stop fairly quickly too. So anyway, I wanted to show you how you can take different things that you have and just, you can just bundle up and take them in. The thing, oh, and the cast iron, since the cast iron is the heaviest, it's going to have the most overall heat in it. Okay. Years ago, we bought and I wish I could find it, but I don't know where it is. They had advertised a space age material that would help you defrost things like hamburger and chicken breast and things like this far faster than anything that you could do other than put it in the microwave, which we know kind of cooks the stuff as well. And they made a big deal about this being this space age material, and they made it sound like something brand new had been invented, and really all it was a big block of aluminum. Yeah, but it was food grade, so you could defrost things safely and all like this. And you don't see them advertised anymore, but it was pretty cool, and it does work. If you have a nice piece of aluminum, perhaps maybe a little heavier than a lid or something like that, it will help you defrost pieces of food that you may want to get at. If you want to defrost some hamburger quickly or something like that, get yourself a big block of aluminum and you can put it on there and it works. It will stop eventually because eventually it sucks all the heat out of the whole object. Okay, but again, this is something that you can do with stuff from home. Okay, thank you very much.